Okay, continuing on example 1, part E now. So now this is a little more complicated because there are variables in it, but they function the exact same way. We're going to start by multiplying, and then we're going to simplify. So I'm going to multiply the coefficients. 6 times 10 gets me 60 outside the radical. I'm going to multiply the numbers inside the radical. 3 times 8 is 24. And then we got to remember some algebra for x squared times x. Remember, squaring a number means to multiply it by itself. So, quick sidebar. When I say x squared times x, well, if you kind of ignore temporarily the times x, x squared means anything times itself, x times x. So if I take that x squared and multiply by x, it just means I have those two x's times a third x, which means I have the same variable x multiplied by itself 3 times. So this is x to the third. So when I do x squared times x, inside the radicals and x to the third power. So we've multiplied, I'm going to simplify. The 60 does not need simplified, it's just the stuff inside the radical. There are kind of two parts to this though. So first I'm going to deal with the 24. 24 can be broken apart a number of ways. I'm going to use 2 times 12, so I automatically get one of my prime numbers. I'm going to keep breaking apart 12. I'm going to get 2 times 6. I'm going to break apart my 6, 2 times 3, and I'm at the end of the line. Those are all primes. There's still something else under the radical. That x cubed matters. So remember what I just said. X cubed is the same thing as x times x times x. So that's what I need to think here. If I were to think of it as a prime factorization, I mean, this is weird to do x squared times x, but the important thing is x to the third power is x times x times x. So if I want the true prime factorization for everything under this radical, yes, there would be the 2 times the 2 times the 2 times the 3, but there would also be an x times an x times an x. And out front, 60 is still hanging out because it's not under the radical, so for a moment I don't care about it. Pairs make perfect squares. So again, since 2 times 2 is 4, the square root of 4 is 2 again. So joining my 60 will be a 2. And I'm going to keep looking for pairs. There's no more 2's to pair up. There's no more 3's. There is a pair of x's. Pairs make perfect squares. The square root of x squared is just plain old x again. So this 2 times 2 became a regular 2. This x times x became a regular x. Inside the radical is everything else who didn't get paired up. So the 2, the 3, and the x. And then I'm going to clean up what I have. 60 times 2 is 120 times an x. 2 times 3 is 6 times an x. Our final answer is 120x square root 6x. So similar idea, but those x's do complicate things when we go to multiply and simplify. Let's do another one like that. So multiply, simplify. My coefficients, the numbers out front, are a 13 and a 2. 13 times 2 is 26. Outside the radical still. Inside the radical is the 10 times the 5, which is 50. And then an x squared times an x squared. So just as a reminder, I'm going to squeeze it in over here. X squared times x squared, which just means I had an x times an x, which is x squared, anything times itself, times another x times an x. It means I have that x 4 times. Even if you completely blank on the rules of exponents from Algebra 1, the fact that you are supposed to be adding your exponents when you're multiplying here, you can still reason out that that is x to the 4th. So again, that was from my multiplication stage. I'm going to have an x to the 4th here. So I've multiplied. I'm now going to check the number, the stuff, all the stuff inside the radical for the simplifying. So I see a number in there. I'm going to start with the 50. I'm going to break it up. I know 50 is 5 times 10, which gets me a prime number. And 10 is a 2 times a 5, so 2 more primes. Those are composite. They're broken apart. I don't care about them. So 26 not changed. But the 50 is now a 2 times a 5 times a 5. I do usually write these small to large. I don't want to write 5 times 2 times 5. I like my numbers kind of grouped together. It makes pairing the numbers up a little easier. So just a quick sidebar with that. Again, we do have to care about the x to the fourth. I could break it apart in weird ways, but I do know x to the fourth is an x times an x times an x times, well, that was weird, a fourth x. So you don't have to necessarily write that out, but it might be helpful to remember that that's what x to the fourth means. So that's what I'm going to put in my prime factorization. X times an x times an x times an x, all under the radical. Pairs make perfect squares. Well, I see a pair of 5s. 5 times 5 is 25, and I know the square root of 25 is regular 5. So joining my 26 is a regular 5. I see a pair of x's. X times x is x squared, and a square root cancels out that perfect square. So 2 x's outside my radical is a single x. Pairs make perfect squares. I see a pair of x's here. So joining all this other stuff out here is this x. Inside the radical will be anything that didn't get paired up, which is just this lonely little 2. So I'm going to multiply everything back together, and I'm blanking on 26 times 5. Sorry, 130. I could have done that in my head, but it's late for me. 130. And as I mentioned before, anything times itself, x times x, that's the same thing as squaring a number. So x squared is outside the radical. Root 2 is the only thing left to be inside our radical. So be careful with those exponents. We do have to remember some exponent rules, but take your time to write out those steps, because I think that is usually where students trip up when they're trying to go too fast on it.